Hello everyone, I'm going to do one last polymorphism class, so let's begin with that. I want to just give you a quick heads up. So originally, or normally in a class, with this class, we have a number of students that are confused. That's somewhat expected. I don't like it, but at the same time, there's always a certain number of students that are confused. I've just come to terms with it, I guess. I don't like that idea, so I like having practice with a lot of stuff. And that's really what this class is about, or this particular lecture is about. Just going over more examples. And if you look at the outline for the courses for this term, I actually have, after we cover polymorphism and inheritance and stuff like that, I have an entire week of just like catch up, deal with objects. The catch up and deal with objects lectures, if I'm doing a live lecture, would be just more examples and more examples until it finally kicks in. Right? The first time, or the first pass at something is not necessarily the one that's going to stick in your head. You may not get it right away. That's fine. We just need more practice doing it to make sure that you're comfortable with it. And so that's what the next series of classes would have been, except for there's no point doing more. Like I can give more examples, but oftentimes it's just people need time to play with the concepts, deal with it themselves. And I'm also extremely long-winded, if you couldn't tell. So my suggestion, at least, is that I'm not going to record lectures for the catch-up classes, if you will, the classes where I just go over more examples. We have these synchronization lectures where I'll do more examples there, and you can just catch up on the videos that I have recorded for the week. I think it's immediately after a reading week. So if you were behind in the lecture videos, you have time to catch up. You have time to do a lot of these examples that we're supposed to be doing. And for the love of God, please do these examples. So I found this online when I just keep on telling students, and they probably don't believe me, or maybe I think they don't believe me. Oh, I don't have a gift for programming, or oh, I can't do it, or oh, it's just too hard. And I always think of musicians and artists, or any number of other professions. Pretty much anything that you do, even stand-up comedians, it turns out. I've listened to Conan O'Brien, he's a friend, a lot, and he's obsessive with the fact that even comedy, which you think, hey, just people are naturally talented. No, there's a work ethic involved. There's a practice. There's putting in the hours to get your craft done correctly. Some people have more of a head start. They may be more gifted, but it all comes out in the wash because there's always someone, no matter what. You're never necessarily the smartest person in the room. You're also not necessarily, even the smartest person in any given room, though, has to practice, because there's always someone that's just as smart. Almost pretty much there's always someone else around them that's just as smart that is practicing. Right? You cannot just go off of other talent alone, and it's not necessarily a talent thing. It's a practice thing. So talent and practice makes you exceptional, but practice gets you 99.9% of the way there for almost anybody. So I'm not a great musician. I'm a clunker, as my dad would call it. But at the same time, I can still play the piano. I can still play the saxophone. So, when you talk to a musician, how do you perform so well? Practice. It must be an innate gift. No, it's practice. I'll never understand how people could be so talented. No, it's practice. Right. Ultimately, nobody gets good at the piano naturally. Some have a head start with certain things. My son is more gifted at piano than I ever was, but he still has to practice the darn thing. And that's what I'm trying to convey here. While you're coding, some people may naturally get some of these concepts faster than others. That does not mean that they do not need to practice. It does not mean that you cannot compensate for any struggles you have with your coding. It requires sitting down and coding stuff. So, what we talked about last time, we talked about polymorphism, and I talked about not killing my kids. So when we do polymorphism, we want the right function call for the right person, or the right class. And so if I have a parent class, that when I say order drink, the parent class means get a beer. When you have a child class and you call it order drink, you want it to order the appropriate drink, not a beer. Otherwise you kill my kids. So please don't. Instead, what we had when it comes to runtime polymorphism is that we had a virtual table where I have a pointer. Every single object that I make, every single one, has a pointer to a table. That table is a lookup table. it says where the appropriate function is located, where in memory, like where's the paint function defined. So I have a if I call paint in the SS shape thing, I go to the paint, the virtual table, I look up where paint is defined. Oh, it's defined over there, and I go over here. It's this sort of roundabout trip to find where things are located. When I call paint here, I go to my virtual table, it says, oh, it's defined over here, and I go back. If I call get area, I go to my virtual table. Oh, get area was not defined in the child class, it's only defined in the parent class. I go up here. When I call get area in a circle, I go to my virtual table, and the get area function was redefined, so I go back to the circle class. It's done on the fly at the last possible second. When I make the call, I figure out where I go. That's what runtime polymorphism is. I figure out what function based off of currently what's being called, not at compile time. So let's look at linked lists yet again, and then we will do an exercise. That exercise is left for you guys to do. Many of you will not do it. Many of you will not even see this video. I get very jaded and bitter about that sort of thing. Many of you may not do the next exercise. I'm begging you, please try and do the next exercise. I'll make sure it's available for you guys to do. What I wanted, and what I was doing before was I would do it as an in-class exercise, and then I'd have the answer to the quiz on my hand. And so when you showed me your code, no matter if it was working or not, no matter if and explain it, no matter what, you show me your code and I say, oh, you could fix it this way. Right? Just see how people were doing, and then give you the answer for the quiz. And so in order to take the quiz, you would have had to actually tried. That's all. But that is what's required to get up to speed. And people resist trying to code because it's intimidating at first, but you will not get good unless you practice. Okay, so let's do linked lists again. I got a bunch of changes in my linked list, so let's have a look at this. So here is my linked list. That's polymorphism. That's small. There you go. Here's my linked list polymorphism. I changed things a tiny bit. I changed this because I'm going to make two linked lists. This is the change I made. So I made a linked list and a doubly linked list. They're both linked lists. This just happens to be a subtype of linked list. I'm going to make a bunch of data types. Fine. I'm going to insert a bunch of data to my first linked list. I'm going to insert 3 data points into my doubly linked list. I also found out something really weird about C++, that if I have overloading and a child class, so I have a child class, if I try and overload it and I don't define the same function again in the child class, it doesn't let me do it. It's weird. So I had to insert it back for a number like I did before in the doubly linked list class, not just the parent class. I thought that was really weird. Okay, I can add data 3 to my doubly linked list as well. I've already defined that thing. Okay. All these things should work well. And now the next part. I am going to, so I've inserted a bunch of stuff into 2 different linked lists. I have 2 linked lists. One is a doubly linked list. One is a normal linked list. Okay, that's it. Next, I'm going to put them all in. I'm making an array of pointers to linked lists because sometimes I need that sort of thing. When we deal with the shapes, the drawing thing, I will have an array of pointers to shapes. That's the only way of doing it. I cannot make an array of shapes right away because I don't know how many shapes I'm going to need. I might need 1, I might need 17. So let's change this code a bit. Let's make it a 3. We'll make 3 of these things, and a list 2 is equal to null, right? And maybe what I can do is, instead of this, I'll do a for loop for int I is less than 3, I plus plus, and I could say if a this at position I does not equal null, and I'm going to say a list at I, and that's going to, I'm going to call this, and I am going to print. All right, instead of what I had before. Let's make it simpler. Notice if I happen, instead of this, I put a pointer back to my doubly linked list again, it'll handle it, right? I just printed off that same doubly linked list twice. I might make an array of, let's say, let's make it int ll. Let's do this. Array size, and I'm going to make it a constant, and I'll make it 5, and I can just use let's make it 3. Keep it at 3. I can then do this. All right. So no matter what I put in this, I can make this 20 different linked lists. I can do whatever. You know, I have an array of linked lists, of pointers to linked lists. If I didn't have this pointer thing here, I'd make those linked lists immediately the moment I make that array. That's what I don't want that. I don't know how many linked lists I'm going to necessarily have. I don't know how many shapes I'm going to be drawing. So I have an array of pointers, and I can set that array up. So, the first two have pointers to a linked list, and then the last one's null. And if it's not null, then I'm going to call print. What I don't want to know is, let's do this and not change anything around. 1, 0, let's say, or maybe let's make that 1, 2, and that's a 0. Let's do it that way. Doesn't matter. I don't want to have to know what that's pointing to. They're all just linked lists. I want to just call print on any one of them. I don't want to know which kind of linked list it is. Don't have to figure out what type it is. I just want to just say, okay, print it off. As long as it's not null, print off whatever the heck it does. Okay. So we should be able to compile this. And when I run this, you'll see me print off these 2 linked lists. Easy breezy. So what we should see is the first list will be the longer list. The linked list has more, this linked list here has more items. And then we're going to print off this one here, which has, like, I think 3 elements on it. Okay, anytime you want. There you go. So here's linked list 2, the doubly linked list. Here's linked list 1. Okay, that's it. Now the real fun part. In my linked list class, here is, where is it now? Print, right here. What if I want my doubly linked list to be printed off differently? That's the kicker here. So if I want the doubly linked list to be printed off differently, let's say have it like has a different format to it. Maybe I can do this. So my linked list, my doubly linked list. I just commented this out. I'm going to put print. Okay, my doubly linked list .cpp. I'm going to go down to my print method, and I'm going to get rid of this comment. And this I need to use a standard namespace. Okay. Okay. So here is, where's my print? I just search for it. Print. Oh. Here's my print function. It's going to, the list is empty. I'm going to do a cout statement. I'm going to say doubly linked list as the output statement, just to make sure that everyone knows what's going on here. I'm going to go to each one of the nodes. And so while each of the nodes are, for every node that is not null, I'm going to go to the null. I'm going to call print node on the node. And then I'm going to get the next one, and I'm going to keep going. I'm also going to want to update my linked list node. My linked list node here is going to have, let me see here. Do I have a print method in here? No, I do not. So let's put one in. void print should be the exact same as the other one. Void DLL node print. Is it print node or is it print? Let's have a look. Linked list node has print node. Sorry, not print. Print node. It's going to look almost exactly the same. So I'm just going to copy that one. Here's my linked list node. I'm going to plop that in there. Doubly linked list node, and it's called print node. All right. So my doubly linked list node looks exactly the same as my linked list node. They print the same way. Oh, cout is not defined. I need to use it standard namespace, or I can use std : and that should do it. This data is of type. Oh, I might not be able to do that one. So data dot. So do I have access to data? I don't think I do. Can I get the data? Well, I want the number. I don't know if I have access to the data. Let's look at linked list node. The data is in a private variable. Okay, I'm going to need to change that too. I'm going to make it protected so only my children can see it. I'm going to put that a line above, and we're going to say protected, and I'm going to have ll data get data. I'm going to go through a function to get the data. I'm going to copy this, save it now. I'm going to go here, and I'm going to just drop this thing in here. LL node get data, and then I'm going to return data. Okay, that's fine, because the doubly linked list node did not have access to the original data, which is, I'm surprised I had that. I thought I would have had it protected, but no. So I'm going to call get data on the parent. That'll give me some data, some type of data, and then I can get the number for that. Okay. Here's what I'm going to do. I'm going to change this around, and I'm going to change this string that I'm putting between these things to be, let's say, an arrow. That's the doubly linked list. So it's going to be doubly linked, or maybe I just keep it as a D for doubly linked list. So D1, D2, D3, and there's doubly linked arrows in between each. That's what I would expect. So for printing of the node, I print off this and I put an arrow in between each. There'll still be an arrow at the end, but that's not the end of the world. I could also get rid of the arrow at the end, but let's keep it simple. Let's compile it. Let's see what happens. So let me reiterate what I'm doing. I made a brand new version of print for doubly linked lists. Oh, I have something wrong with this. And the print function for linked list is already defined. Print node is already defined. For linked list, okay, where's linked list? Print is already defined. Linked list. Oh, I know what I did wrong. Hold on. Because I call it linked list. I didn't call it doubly linked list. That's this particular version of linked list. Okay, let's start this again. And I don't have, that's a private variable, so I'm going to need access to this. Get my start point, and I'm going to move through that. Okay. Let's compile it again. Let's see. So I've made a brand new version of print for my doubly linked list. It's different than my linked list one. It will, instead of saying linked list, colon, and then a bunch of linked lists, it says doubly linked list, and each of the linked list nodes, each of the nodes each of the parts, are going to look different. They have that double arrow in between. So what I would expect, or what I would hope, is let's go to my, where's my main? Hello main. What I would expect is I'm calling print on each of these linked list nodes. So when I get to a doubly linked list node, I would expect a different format for the printout than the singly linked list node. With me so far, hopefully. I would expect the format to look different. I will give you a warning in advance. It is not going to look different because we didn't call virtual on it. But let's have a look at this thing. Here is the doubly linked list. Here is the linked list. In both of these cases, I am just calling the print method for linked lists, not for doubly linked lists, despite it clearly being a doubly linked list. I don't want to have to know, oh, it's a doubly linked list, I'm going to call this thing instead. What I want is I just have it work. So I'm going to go to linked list.h. I'm going to go to this print function, and instead of just print, I'm going to call virtual so that it is the print function works for that. And I'm also going to be kind of obsessive, and I'm going to put virtual in front of this thing too. Because what I want is to make sure that when I look at this thing, I go, okay, that thing is virtual. Let's see if there's other things. Insert at front, insert at back, insert at back. Any other virtuals in there? No. Just in case. They're already in the other one. Okay, what happened here? LL main, the permission was denied. Let's have a look. Double linked list. That might be, the problem might be up here, so let's just get rid of some of these. I'm just testing something out here, so. Okay, that worked. I have a sneaky feeling that the linked list.h has virtual on the insert at back and insert at, okay, they're both at just at insert at back. Virtual. That should fix its wagon. There you go. It was because I had a virtual up here, but the parent class didn't have that virtual, and I think it got confused. Okay. So if I do this, what would I expect? I expect when I call print, it's going to say, it's going to go to a virtual table. When I get to the doubly linked list, it's going to go to a virtual table with that object and say, hey, which print method are you calling? And it goes to the table, says, oh, you mean the one that's in doubly linked list.h, and it jumps back to doubly linked list.h. We're going to see something else wrong with this, by the way, just letting you know. There we go. And it says they're doubly linked list versus linked list, but notice we changed the thing in between. Instead of this tilde, I made it an arrow now. So it's still wrong because I didn't make the child class a doubly linked. I didn't do the virtual thing for the child class as well. So I'm going to go to my, where is that linked list node? I'm going to get data, get next. That's fine. Print node, there it is. I'm going to put a virtual in here. I'm going to go to my doubly linked list node.h. I'm going to put virtual in here. I'm going to save it. I'll compile it, I guess, and that automatically saves it. And then I'm going to run it one more time, and hopefully we're not going to get a compiler or some kind of runtime error, but let's find out. There it is. I'm calling the right doubly linked list node function, and for the linked list nodes, I'm calling the right function for that one too. All I need to know is I need to put the word virtual. If I have it work differently, on the children versus the parent, and I don't know if it's a child or a parent, if I don't know what class it is, I just know it's a linked list, then I need to have virtual methods. I need to figure out on the fly, when I'm running this thing, what kind of object it is. What class is it? And so this is my print method using virtual functions. I said, if you look at my comment here, it's just so I wouldn't forget it. I had another comment to myself. Fix the fix for L12, and I'm going to fix all the casting to doubly linked list nodes. So let's have a look at where those things are. I'm going to just do a search. Okay. If I need to get the start, that one actually might have to be kept alone. Why? Because I'm going to call get start. I'm going to get the starting value, and I need to say, look, no, it's a doubly linked list node. Okay, that one I need to keep. I cannot use a virtual function on that one. Same with get end. If I needed that, if that's inserting at the back. And get start, get next. I think I might need to keep all these. Okay, so that's actually all fine. I can't actually get rid of any of those casts but notice I'm in a doubly linked list node object. So knowing about what a doubly linked list node is, or I'm in a doubly linked list, knowing what a doubly linked list node is, that's acceptable. The parent class shouldn't know anything about these doubly linked list nodes. The parent class should just magically and sort of naively assume there's only one kind of linked list. If you make a child class, the parent shouldn't need to know about the child class. In a very similar way, your great ancestors know nothing about you. Unless they could predict the future, they didn't know you would be born. Right? The parents do not necessarily have to know about like subsequent child classes, because it leads to a really hard code to understand. You want to keep it simple. And so as long as the parent doesn't know about the child class, you're fine. The child can know about the parent class, but not the other way around. Okay. So that was just linked lists yet again, looking at how we go about, when I call a print method, I want to call the right print method depending on what kind of linked list I have. If I had insert at back and insert at the front, and I didn't know what kind of linked list I was dealing with, well, then I need virtual functions again. If I don't know the kind of child class it is, if it's the parent class, if it's a child class, the grandchild class, if I don't know what the class is, I need virtual functions. Okay. So here's the your turn part of things, and I'll just talk it out. I'm going to post my superstrings code that I worked on previous terms. I think they even have a couple examples in there. But I really want you to do it on your own. So this is normally an in-class exercise. I'm going to ask you to make a class called superstring. It takes in a C string, so a character array, and it deals and acts as close as you can, within reason, to how the string class works. So if my character array is not large enough and I concatenate something to the string, I automatically adjust the size of my array so that I can add the new characters in there. Or perhaps it has a constructor and a destructor to make sure that I don't run out of space. Or you can do all sorts of different things with this. The idea is that instead of a C string, which is just sort of very bare bones stuff, I make a class called superstring that does almost exactly the same as the string class, and you get a feel for how to make an object. Okay, that's not all that interesting. The interesting thing is when you make a child class of that string class, that superstring class. And you can do whatever you want with this. So I've had people do all caps for screaming. I've had people do reversing the strings. I've had people say R at the end of every string. It's your choice whether the actual data being stored, the character array being stored, is modified, or we keep the character array as it is, and just when you go to print off the string, or when you're trying to return the actual string out, that you capitalize all the letters, let's say, or you make it, I think we had ransom notation last term. Some people were doing ransom notation, so they made it upper and lower case across the way. Great. And so when you go to call print text, I think is the name of the function, it will make the characters upper and lower case. The original text is just text, but when you call print text, what gets returned is this upper and lower case text. Or maybe it has R at the end for pirate strings, or maybe it's all caps, or maybe you can mutate and change the string as you go, right? To sort of have fun with it. But what you want to know is, you don't want to know, what you want to be able to do is make a string, make one of your child strings, like the pirate string, let's say, and you don't know what kind of string it is, but it still prints off perfectly fine. So you make 4 normal strings, 5 pirate strings, throw them all in an array of strings, pointers to strings of these superstrings, and then you just call print text on each one of them and see what happens. This will take some time. I fully admit that. But it should be fantastic practice for you to get your head around the concept. It's a small enough problem that you need this practice. And I think even if you don't go all the way to the end of it, I think this practice will be what you need to make sure that you have to make this concept your own. And this will help cement your knowledge of how strings actually work. Okay, so for our take-home lesson, we looked at object-oriented design, we looked at inheritance, and we looked at polymorphism. They're finally all working together so that the object knows about itself. Nobody else needs to know how the object was implemented. I don't need to know all the variables in the object, and I sure as heck shouldn't get direct access to those variables in the object. I also don't want to repeat code, so I can make a subclass of a class, right? I can make a subclass that just takes all the code from the parent class and tweaks it a little bit. So that's inheritance. And then if polymorphism allows me to have multiple different functions or multiple different types of variables and just treat them in different ways. So 2 ways of calling the same function depending on the parameters being called. Or in our case of runtime polymorphism, when I call the function, it figures out what class the object is and calls the correct function accordingly based on a virtual table. The function is based on the object, not the class. The individual object knows what kind of class it is. Even if you say it's a linked list object, the object itself knows, no, you might call me a linked list object, but really I'm a doubly linked list object, right? You're not just Carleton students, you're BIT students, a special kind of Carleton student. That sounds like pandering. It's not meant to be pandering. So what we want for polymorphism is the data and the functions depend on the context, depending on how it's called. So we get the same name, same functionality. Sometimes we want the same symbol, but different functionalities. The functions work on the context of how it's being called, which is way more intuitive than having to try to shoehorn your data into however they define this class. And you don't want to have to know about the class hierarchy. You don't want to have to know that there are 4 child classes to the superstring class. You just want to call superstring.print. You don't want to have to know how everything is laid out or how things are structured. That's the point. There is nothing worse than trying to understand I understand how frustrating it is to understand somebody else's code. The reason we have polymorphism is so you don't have to understand other people's code. You can just call their functions and not have to understand what they did to get that. Subclasses are supposed to be treated like the parent and yet tweak things a little bit. They override what the parent's functions do when they need to. And so with that, what we'll do next time around is we're going to look at, I think we're going to be looking at events and model view controllers and Microsoft Foundation classes. If you are a Mac user and you have not installed a virtual machine yet, please do so now. I'll remind you when we get to that other class as well. You cannot do the assignment without a virtual machine. So please install one now. It is what I'm sort of put into position to make sure we do something like Microsoft Foundation classes. So, and because everyone's expected to have some kind of Windows machine or be able to have a virtual Windows machine, you're expected to be able to run MFC. All right. So with that, I will talk to you guys later. Thanks.